Hi students, today I'll be sharing with you the solution of question number 9 and question number 10 of your exercise 6.2. So read the question carefully. In this figure you are given with AB is parallel to CD and you need to prove that AO upon BO is equal to CO upon DO. So in proof, before going to prove this, you have to think that what topic we are doing. Again, we are back to the application part of your basic proportionality and its converse. And I am very much clear that somewhere I have to apply basic proportionality or its converse, and that I know very well, which is applicable only and only to a triangle. So somewhere if I take this EO is parallel to DC, EO is parallel to DC, that is a construction I have done, EO is parallel to DC. Now comfortably I am in position to apply the basic proportionality theorem, which states that in any triangle, if there are 2 points on any of the two sides, the line joining those 2 points, if is parallel to the third side, divides those two sides in equal proportion. So let us see what happens here. After this construction, AE upon DE, AE upon DE will be equal to what? AO upon OC, isn't it? And the reason is very simple, that is your basic proportionality theorem. Similarly, please name the triangle here. This is in triangle ABD. So ABD I have applied. Similarly, you see this result, this result I have applied in triangle ADC, ADC, ADC. Now in triangle DBA, DBA, because AB is parallel to CD and you have drawn EO is parallel to CD, so this EO is also parallel to AB. EO is also parallel to AB because AB is parallel to CD and EO is parallel to DC. This we said by construction and this is given to us. So on this behalf, I can say that this EO is parallel to AB also, but now the triangle is DBA. So again, I am in position to apply the basic proportionality theorem in terms of DE upon AE. DE upon AE is equal to what? This upon this is equal to DO upon OB. DO upon OB. Again, the reason is what? Basic proportionality theorem. So first I applied basic proportionality in ADC. This is the triangle, and second time I applied the basic proportionality theorem in triangle DBA. So here if you see AE upon DE, and this is the totally reciprocal of AE upon DE. So I can take the reciprocal just to compare the results. From here I will be getting AE upon DE is equal to OB upon OD. So by taking the reciprocal. So now if this is result number 1 and this is result number 2, AE upon D, AE upon D, I can conclude that AO upon OC is equal to what? OB upon OD. What I need to prove is AO upon OB is equal to OC upon OD. So either you go for cross multiplication and then arrange this accordingly, or the property which we can use here, that is called alternando. If this upon this is equal to this upon this, then you can say that this upon this is also equal to this upon this. So I can conclude that AO upon OB is equal to OC upon OD. This is by alternando. This property is known as alternando. Again, I will make it very clear to you. If this upon this is equal to this upon this, then this upon this will always be equal to this upon this. You can try in any of the ratios from your understanding point of view. So this is the solution for your question number 9. Now you go for your question number 10 and you see that is exactly the converse of this question number 9. So what I need to prove there is this. this is now given to me. This is given. So again I need to go for the same construction, and then in my proof you see what you can do there is, now you need to prove this AB is parallel to CD. Suppose I've done the construction here, U is parallel to CD. So if U is parallel to CD, again I'm in position to apply that theorem, that is AE upon ED is equal to what? AO upon OC. This is in triangle ADC. And as I did the construction, so EO is parallel to CD. EO is parallel to CD. So I have applied the basic proportionality theorem there, and I will be getting AE upon ED is equal to AO upon OC. Now my target is to prove this CD is parallel to AB. So if CD is parallel to AB, again you see now, if I go back to this triangle here, that is your DBC, if this is parallel to this, but I said that EO is parallel to CD, if somewhere I can prove that EO is also parallel to AB, then by comparing the results, I'll be in position to conclude that AB is parallel to CD. So you just can think that how we can go for the same, that is AE, what is given to you now, just be focused there, AO upon BO, AO upon BO. So as given is what? AO upon BO is equal to CO upon DO. So I can say that AO upon CO, again by alternando, AO upon CO is equal to BO upon OD. So now you see, this is your result number 1 I am taking, this is the result number 2, because as given, so I have applied that, and then by alternando I said if this AO upon BO is equal to CO upon DO, then AO upon CO will be equal to BO upon DO. So now this is also AO upon OC, this is also AO upon OC. So if I'll compare, so I'll be getting AE upon ED somewhere is equal to what? BO upon OD. So now we look at this, AE upon ED is equal to what? BO upon OD. That means now somewhere I'm talking in triangle ADB. So therefore, in triangle ADB, by the converse of basic proportionality theorem, if you are getting this, take the reciprocal, DE upon AE is equal to OD upon OB. So DE, that means this upon this is equal to now what? This upon this. So this implies that this OE is parallel to AB. OE is parallel to AB, that is by the converse of BPT. By the converse of BPT. Now this upon this I have proved first is equal to this upon this. So on this behalf I can say that OE is also parallel to AB. So what construction you have done? OE you said is parallel to CD. So if OE is parallel to CD and here you have proved OE is parallel to AB, so that means your AB is parallel to CD, which I have to prove. So that is the solution for your question number 10. I hope you all understood that. Now in exercise 6.2, yesterday the basics of your criterion I shared with you, and those three were your SSS, SAS and angle, if you remember. So feel free to apply as per the availability of these criterions or your convenience point of view. You please go through your exercise problems. Few solutions I will be sharing with you, and in a sequence of your NCERT textbook, you just can see first question. I hope very good pairs are there in all 6 parts if you share, and question number 2 of the same exercise, oh, I hope all of you can comfortably get that solution also. Why? Because this is simply based upon your either the properties of your lines and angles, or you need to compare these criterions within these two triangles which you need to prove similar. Very interestingly, let us share the question number 3, because today I will just come up to question number 3 or 4 with you. Then next questions I will be sharing with you tomorrow. So question number 3, once again, diagonals AC and BD of a trapezium ABCD. Because I shared this question with you right now in your previous exercise, that was question number 9 and 10. And in a trapezium, you know the opposite sides are always parallel. So AB is parallel to CD. They intersect each other at O. Intersect each other at O. So here it is. Using the similarity criteria, now the question is conditional, and once again I need to prove the same thing, that is OA upon OC is equal to what? OB upon OD. OA upon OC is equal to OB upon OD. OA upon OC is equal to OB upon OD. So now you see these two which I need to prove, OA upon OC, this upon this, is equal to OA upon OC is equal to OB upon OD. Means I can think about these two triangles OAB and OCD. So you say OA upon OC. If I can prove these two triangles similar, then their corresponding sides will always be in proportion, because the question is conditional. Now I have to use the criterions to prove this relationship. In previous question, that was known to me in previous exercise, because I was just applying the properties of your either the basic proportionality theorem or its converse. So I proved in that way only. Now here if you see, if this is parallel to this, angle 1 is equal to angle 2, means somewhere I am getting angle B is equal to angle D. And then you see this vertically opposite angle AOB, this is 3, and DOC, this is 4. So AOB is, here it is 3 and here it is 4. So these two, so come back to this criterion. So how interesting it is, and very easy. As I said, most of the time you try to find out if any of the two angles you are getting equal, then those triangles are always similar to each other. So once you have proved these triangles are similar to each other, then in proof comfortably you can say that this upon this, that is OA upon OC, is equal to this upon this, that is OB upon OD. Their corresponding sides are always in proportion. So that is the solution of your question number 3. Onwards, question number 4, I will come back to you tomorrow. Till then, you can please go through the solution of these. See you tomorrow. Thank you.